Hi, my name is Anna. Welcome to this journey through the future of intelligent operations and supply chain efficiency. Today, we are going to study the chapter, which is Integrating Robotics and IoT for Predictive Maintenance. In this chapter, we'll explore how predictive maintenance works, how it has evolved, the key technologies behind it, and how robotics and IoT are used to anticipate problems before they happen, ultimately reducing costs, boosting productivity, and improving asset life. Let's get started. Introduction to predictive maintenance. Predictive maintenance is the modern way of managing equipment health. It predicts problems before they happen. This is a leap forward from older strategies like reactive maintenance, fix after failure, and preventive maintenance, scheduled fixes. Predictive maintenance uses real-time data and smart analytics to tell us exactly when maintenance is needed. That way, we avoid unnecessary downtime and extend equipment life. This approach can cut maintenance costs by 30 to 40% and reduce breakdowns by up to 75%. Key components of predictive maintenance. There are 4 pillars to this system: data collection, analysis, decision-making, and execution. First, IoT sensors collect data such as vibration, heat, and pressure from machines. Then, that data is analyzed using advanced algorithms to find early warning signs. Once risks are identified, the system recommends when and how maintenance should be done. Finally, these actions can be performed by either human technicians or robots. This pipeline turns a messy process into a smart, data-driven operation. The role of IoT sensors in predicting failures. Think of IoT sensors as the nervous system of modern machinery. These tiny devices constantly measure performance. Vibration sensors catch imbalances, thermal sensors detect overheating, and acoustic sensors pick up strange sounds. There are also electrical and fluid sensors for more complex systems. Today's sensors are compact, wireless, and energy efficient, making them easy to install even in hard-to-reach equipment. They give us eyes and ears inside machines we couldn't monitor before. IoT sensor implementation and data flow. Here's how the system works. Sensors acquire data at set intervals or even continuously. That data travels wirelessly via networks like Wi-Fi or 5G to computing systems, either on-site, edge, or in the cloud. It's stored in databases where machine learning algorithms then detect issues and predict failures. This continuous data flow creates a digital twin, a virtual replica of a machine's condition. That way, companies can simulate and predict outcomes before they become problems. Robotics and IoT for monitoring equipment performance. Sensors alone aren't enough. They're static. Robotics brings mobility to the monitoring game. For example, autonomous mobile robots, AMRs, can patrol a plant and inspect different machines. Drones inspect roofs, cranes, and other high places. Crawlers go inside pipes or tanks where humans can't. Robotic arms can even run precise diagnostic routines. Together, robotics and IoT create a multi-layered inspection system that no single method could achieve on its own. Slide 6. Advanced robotic monitoring technologies. Let's talk specifics. Aerial drones equipped with thermal cameras spot overheating in overhead equipment. Crawler robots use ultrasound to find corrosion or cracks inside pipes. Robotic arms perform inspections using vision and force sensors. These tools aren't science fiction. They're already helping businesses perform inspections with better consistency, safety, and accuracy. They also collect far more data than manual inspections ever could. How IoT and robotics enable data-driven maintenance decisions. When you combine the constant data flow from IoT and the reach of robotics, you create an integrated decision framework. This means the system doesn't just monitor, it understands and recommends. It can determine what's failing, why it's failing, when it might fail, and what to do next. This integration reduces guesswork and improves response speed. For managers, it means better planning, less emergency maintenance, and more uptime. Advanced analytics for predictive maintenance. Predictive maintenance depends heavily on four kinds of analytics. Descriptive: what happened in the past? Diagnostic: why did it happen? Predictive: what could happen next? Prescriptive: what should we do about it? This progression helps companies move from reactive to strategic maintenance. The more advanced the analytics, the more confident and efficient the decision-making becomes. Reducing downtime and operational costs with predictive maintenance. Here's the business value. Predictive maintenance reduces unplanned downtime by up to 50% and extends machine lifespan by up to 40%. It also decreases spare parts inventory and improves equipment effectiveness. But more importantly, it improves safety and product quality. For any supply chain leader, this means fewer disruptions, higher output, and happier customers. Predictive maintenance shifts maintenance from a cost center to a value driver. Cost-benefit analysis of predictive maintenance. The ROI is compelling. Studies show that predictive systems prevent 85% of potential failures. The cost of fixing a failure reactively is up to 10x higher than preventing it early. The payback period, usually just 18 to 24 months. Yes, the initial investment in sensors, platforms, and training is high, but the long-term savings and risk reduction far outweigh the setup costs. It's a smart investment with high strategic value. The role of machine learning in predictive maintenance. Machine learning takes predictive maintenance beyond simple threshold alerts. It can detect complex patterns, learn from previous breakdowns, and adapt to changing conditions. It also connects seemingly unrelated data points to improve predictions. For example, it might link humidity levels to motor failures, something a human wouldn't easily see. With multiple models running in parallel, modern systems can forecast and classify different types of failure with increasing precision. Case studies of predictive maintenance in supply chains. Let's look at real-world applications. Ocado, UK, uses predictive maintenance in its robot-run warehouses, reducing downtime by 60%. Maersk, Denmark, monitors refrigeration containers in ships using IoT and AI, predicting failures days in advance. BMW, Germany, uses collaborative robots and sensors to predict breakdowns with 92% accuracy, saving over $1.2 million a year. These examples show how predictive maintenance works across industries, from manufacturing to logistics. Challenges in implementing predictive maintenance. However, implementation isn't easy. Technically, many companies struggle to connect old machines to new sensors, ensure reliable connectivity, and manage noisy data. Organizationally, change resistance, lack of skills, and unclear ROI make adoption slow. IT and operations teams often work in silos, which adds complexity. Overcoming these barriers requires leadership, training, and cross-functional collaboration to build trust in the system. Future trends in predictive maintenance. We're just scratching the surface. The future holds autonomous maintenance, where robots repair machines without human help. Going further, cognitive maintenance will use AI that understands causality and adapts in real time. Think of systems that not only fix issues but learn from them and get better with each interaction. Combined with digital twins, AR interfaces, and blockchain-based traceability, predictive maintenance will become a core strategic asset for supply chains.